Now that we have seen a simple use case when Docker might be a good idea to use, namely when you want to share your code with others, let's try to wrap a simple application with Docker ourselves. So here's our goal for today, and the plan is very simple. First, I'm gonna show you some command to check that you have actually Docker installed. Then we're gonna build a simple application and run it without Docker, and it will be a Node.js application, and we'll use an Express.js library to create a simple HTTP server with a single route. Then we're gonna test it, and this is a step that doesn't actually include any Docker interaction at all. So this is a simple scenario of creating any application. We don't care about Docker here. And the next step is to create our Dockerfile, install some dependencies, copy project, and then specify a run command. About that a little bit later. Then we run a docker build command to actually create our container, and then we're gonna test a created image before we push it to Docker Hub. So this scenario is very similar to what one person from our previous use case from previous video should do. We'll follow this scenario as well. So let's start. Let's start from this the very first step. And actually, I have already failed one attempt to go through these steps. So let's start with clean folder here. Actually, the first step, let's check that we have Docker installed, and we do it by running any of Docker commands, and Docker specifically for checking that Docker works correctly. Docker has a special image, and you run this special image by command docker run hello world. This is similar to any programming language. A simplest command that will just show you some simple output, just to be sure that everything is configured correctly. Here's our hello world message from Docker image. So everything is ready. My version of Docker is 19.03. And before I continue, let me quickly remove this container from previous attempt. So first step is done. Let's move to the next one. The next one is to create a simple application. Here's our clean repository. Because we are using Node.js, we need to initialize a project. We agree with all the settings here, default values. Yes. Okay, now we have our package JSON file, and because we're gonna use Express.js, let's find out how to run our Express.js, some simple example from the internet. So I'm gonna Google Express.js, and here's example of hello world using hello world server, hello world HTTP server using Express.js. It will basically run on port 3000 and return a hello world string on route here, and it will also output this message to the console when it starts. So here's our simple server, and let's put it to index.js file, save it, And we have almost completed the first step. The last one, yeah, actually we just to remember, we're running on port 3000 here, and to be sure that our application is actually working, before we go to Docker, let's test it without Docker. So you test it with node command, node index.js, and actually it's I think it's written here, node app.js. We have index in our case, so we run node index. We don't have Express installed. Let's install it now. npm install, and specifies flag save dev, and provide the name of our package. The name of our package call is Express. And now we run node index. Here is our message to the console, and we should be able to see it in localhost 3000. Here is our server, here's our response. So our server is running. We continuously listening to requests, and maybe let's make it a little bit more interesting. Let's also console log something to the console. Just to see when a request coming, like so. And now let's move it again, and here's our requests, and we have output for each request, so just for us to see it clearly. Okay, now we finished second step, meaning the first step, not counting the zeros step, and now move on to Dockerfile. And here's a thing: when you create a Dockerfile, think about this way. Let's say you have an empty server or an empty computer, well, running some kind of Ubuntu, Debian, other distribution, and you need your goal is to run your index.js. You don't have a NodeJs, npm, any other package. You have a clean system, and from this standpoint, what you're gonna do manually is exactly what you will use in your Dockerfile. So let's create our Dockerfile, and well, first of all, we need to specify what kind of operation system we want. In our case, let's stick with a simple general purpose Ubuntu of version 16.04. Well, there are a lot of different images, a lot of different systems, and you can go with more specific nodes. Even you can specify a version of node, and this way you won't need to install node and npm yourself. But for the first time, let's stick with the general approach when we specify a Ubuntu system and then install everything that we need manually. And what we need on a clean system to run our application is we need node and npm. And to install node and npm, what you're gonna usually do, you're gonna go to Chrome, to Google, and type something like Ubuntu install npm or node. Here's our link, for instance. You're searching for some scripts that will allow you to install it, that you can copy paste, and I think that it's some install instruction. Here's our instructions, and we need to use version without sudo because Docker file runs everything as if it was a sudo. We need to provide a run command, and whatever comes after run command, is executed inside our image when it will be built. And let's try to build our image now. To build an image, you simply specify docker build, and let's tag our image as an app, and then we specify actually a path to our folder with application that has a Docker installed. And why I want to build it right now? Well, I want to test. We can go with all the configuration at one point, but for now let's try to just install the dependencies without providing any information about our application. For now we're just building a system that has everything to run our application. So let's try to build it. Docker build tag app dot, and here we have an error, and actually the first and the second step were executed correctly, but the third one failed. And you'll get the same error if you follow same operations on a clean Ubuntu server, because we haven't run one single update command before we install anything. And usually on Ubuntu you need to run apt-get update command just to update all the repositories. So actually it's using cache here, and here's why. It should be much slower than that, but because this is the second attempt to record this scenario, and I am using the same image tag as before, and in previous attempts I had the same operations. Docker will use a cached version of these operations just to speed up the process. So I actually have it run very fast here. So just because I'm doing this process second time. So we are ready with our dependency, and now let's move on to our application. To have application on our system, first we need to copy it to our system. To do that, first we need to run workdir command and specify a directory where we want to execute all the following commands. And it will think about this path as being a root for our project inside our image. So then we need to having a root folder for our project, we need to copy everything to it, and you do it with this kind of command, where first argument is a relative path inside our host system, meaning a current directory. Copy everything from a current directory to a relative path inside an image, and in this case it will be /app. If we specify something like that, it will copy everything from our local folder to a root of the image. So, but we want to copy everything to the app. So you specify a command like that, and then we need to run npm install, and because even though we copied everything, and even though we don't actually need to do it in this case because node modules will be copied. But let's imagine that we don't have node modules, because usually because usually you don't include node modules into any version control system, or actually you usually even don't copy it to a Docker, but you ignore it just to save a space inside your image, make it smaller. So anyway, here's our 3 commands, and after that we'll be able to actually run our application inside our image. So let's build our image first. So here's we create a folder, then we copy the content, and then we have some error that says that npm isn't found. And the reason is we need to install npm as well. npm, and all these dependencies that we are specifying here, they'll be all presented if we, instead of using Ubuntu, will use something like Node 14. We'll skip all that because Node 14 is more specific version, specific image for specifically running NodeJs applications. And there are tons of such images for any technology you're using. So let's now try to build it. We have almost all steps cached, and now we're running npm install. As you can see, it's running successfully. It will take some time. Let's wait. Okay, now we almost ready with Dockerfile. We actually installed all the dependencies. We copied project. One thing that we need to do is to specify a command to run the application itself, and you do it with command entry. Actually, there are several. Let's stick with cmd command and provide. Actually, you need to just provide any command that gonna run your application. In our case, we run our application with node index, so we need to specify exactly this command. Node index.js. Now let's rebuild our image. It will start the build with copy. As you can see, previous commands was cached, and from and it starts to actually rebuild from copy command, because we changed the contents of whatever this operator applied to, in this case to our local directory. So we need to rebuild everything from this step on. And here is our cmd command, and this is a quick reference why in this case we used a run command, and in this case we have a cmd command. What is the difference? Well, you see, these commands are executed inside whenever we build our image, and cmd commands is executed only when we create a container. We haven't yet created any containers. We're creating an image here. We'll create a container when we test our image, but not now. Remember, image is a snapshot of your system, and you can start with Ubuntu, and whenever you create an image, install all these dependencies every time, but it will be time consuming, and a better approach will be to have an image that already have all the dependencies, and then you just have to run a single command whenever from this snapshot to run a container. And cmd actually executed when you run a container, and run commands and commands like workdir, copy, on the other hand, is executed when you build your image. So this is how it should be, and our image actually was built successfully. And now let's try to run image. You do it with docker run command. You specify the name of your application, of your image, and it will start the image. If we it actually it didn't start our image because because of this command. It shows us that we don't have a Nodes executable installed, and this is because I forgot that actually when you install a NodeJs package, it will provide you with another executable that's called NodeJs. There is one way to fix this problem. Another way will be to do something like aliasing this binary, but let's stick with this approach. And we need to rebuild our image. As you can see, we changed the directory, so we start rebuilding image from step number 7. And now npm install is running, installing all the dependencies that we have. Here image remembers whatever commands it needs to run when container is created, and now we should be able to run our image, and we're getting the output when the server is started. And if we try to access our URL, it doesn't return anything, and the reason is that even though we specify port 3000, Docker uses a private network for any container it runs. Any container has a separate network, separate local host, and we need to bind our port, our local port, to whatever port inside a container. And you do it with the next command. Well, first of all, we need to to stop this container from running, and I cannot exit this prompt because I don't know why. So you need to open another terminal, and let's see what images, what containers we have running right now. We have a single container, and you can list it with docker ps command. Here's our container, an idea of our container command, how long ago it was created, and a random name that was created by Docker to uniquely identify our container. And you can do operations with either a container ID or a name. What commands? For instance, there is a command called logs. You provide container ID to it, and we'll show you all the logs from the container. And you can stop your container, or in this case, let's kill the container to release our terminal session here. And now about binding the port. You bind your port with a -p command, and you specify this binding mapping, or P stands for publish. You can do it like so. And to enable us, for us to be able to use this terminal when container is running, we need to specify detach flag that will run the container in background, and it won't affect our current terminal session. It just shows us, it won't show us here the output because we're running a detach mode, but here's our full ID of our container, and we can get logs from the container this way. And actually you can specify -f flag to follow logs of your container. And now if we try to access our server, here's it. Here's our new logs, several more requests, all of them are here. So, and this application is running not on our system but inside the container. And with this successfully completed, we have the second step completed and the third one as well. And the last step, and actually for now let's remove our container, because if you run many containers, you might end up with your system overwhelmed by them. And another way to kill all the containers is with command. You see we have a command ps -q to only return IDs of your containers, and you can use a bash expressions like so to kill everything that will be included in this string. And by doing so, you don't need to go here to search for container ID. You can just run these generic commands and kill everything. And if we now try to access a server, we don't have it running. So the next and the last step today is to publish our container, our image to a Docker Hub. Docker Hub is a place that I have mentioned in previous video. This is a place when you might upload your image just to make sharing easier, because our image is a full snapshot of a system, so it weighs some megabytes, like several hundred megabytes if we're talking about Ubuntu based images, and it might weigh much more if you have a lot of dependencies installed in your image. So it's easier to upload your image somewhere and then just to use a URL to share it with other people. So to do that, you go to browser, you open Docker, you actually open hub.docker.com. You need to have an account here. I already have, and here's my repository from a previous run. Let me quickly remove it. Delete repository. Now that I have deleted the repository, let's create an empty one up. It might be private if you want to keep your working secrets from others. Just creating. And here's our empty repository, and by repository I mean a place for to store all the versions of your image. And by versions I mean tags. You need to, well, if you have several versions of your application, for instance your first version is a current version, then you might change something like console login, another line here, right? This will be the second version after you build after you run a build command. And To be able to push to our repository, you first need to connect your local Docker and to authorize your local Docker with your account on in Docker Hub, and you do it with Docker login command. Login. You might check a help message for these commands, and you have two options. You might specify a password and username that you used when creating an account here, or you might skip everything, and it will make you pass these credentials interactively. But I have already logged in, so I should be able to automatically log in to connect my local Docker to a Docker Hub. As you can see, I didn't need to provide any credentials because they're already in my configuration file. I did it one time somewhere previously, and now it will reuse it. So now I have logged in, and I need to tag my image like so with commands git tag. I first specify, let me git tag. I first specify a local tag, and as you remember, we name our tag app, our image app semicolon latest, and then space, and whatever tag I want to name, I want to create. In this case, I want to create a tag app. Well, first we specify ID from the Docker Hub, and this is how Docker can identify where it should push the image to. And by default, Docker will use Docker Hub, so we don't need to provide additional URL option here, but there are a lot of places on the internet, and you can create your own server hosting your custom repositories. And in this case, you will need to specify something like HTTP custom repo.com, and then, well, the full URL. Docker just now knows that if URL isn't specified, it needs to search in Docker Hub as a default option. Latest. Oh, we actually don't need to specify Git, we need Docker here. Okay, now our tag is initialized, created, and now the last step is to publish our image to the repository with a command like that. And I won't wait all the time because, as I said, it will take several minutes, or maybe 5 minutes to push it. Several dozens of megabytes. Okay, and here we have 2000. I won't wait. Let's take a look at repositories that I have here. Let's say this one. After you successfully publish, upload your image to the repository, it will look something like that. You have a tag here, and in our case we would have a latest tag, but here my tags are called like prod, dev, base. And to get this image on your local machine, to copy it on the local machine, you need to provide the name of your image, and one more time you use a Docker Hub ID, and then Docker Hub ID uniquely identify myself, and then the name of a repository, and also the tag. The tag is optional here, so you run command git pull. Actually, you can do it with git run, docker run. As you remember, first command we run in this tutorial was docker run hello world, because hello world is an image hosted on Docker Hub, and it doesn't use ID here because, well, by default, if it's skipped, then it should mean something. In this case, it means that this is a default default account for Docker Hub. So let's try to clone my. Let's try to. First, we need to pull it to local. We need to download it to local machine, and you do it with. Let's copy the base image. You do it with docker pull command. Let's see, maybe I already have it. Yeah, image is up to data, so I don't need to download it. It speeds up the process a little bit. And now to run our image, you need the same command as we did previously with our application while testing it, docker run, and you specify the name and a tag of your image. And here is the way how you collaborate with others. You can pull their images and run them locally. This way, whatever application you want to run locally without caring about installing all the dependencies, well, actually without caring about a scenario that I have shown you in previous video, when one person doesn't know anything about Python but is able to run Python script, or maybe you don't know anything about Node.js. If you clone my repositories we have created in this video, app.latest, you will be able to run this application, right, without ever needing to configure it. So here's our simple app. Here's a video. We just wrapped a simple application inside Docker, and this is a basic scenario, and in 90% of cases it will look something like that. You install more or less everything you install is more or less the same. Install and configure. You might have more images running in parallel. You might have images, you might have containers communicating with each other using each other's network, because you might want to separate different services to run in separate containers to have even more abstraction, but we'll talk about this approach in later videos. For now, I think that we completed all the steps. The last step is completed. So that's it for this video.